All right? So now let's look at one that's a little bit easier, and that's the condensed mixed structure. The condensed mixed structure is one in which I have a ring. So I'm just going to put here rings, okay? The reason is because rings are very, very difficult. If you think about it, rings would be very difficult to draw in a text because a ring could be a certain shape, it's two-dimensional, and most text editors don't give you the ability to draw up and across. It's only to go across. Think that you're on a typewriter. Would you be able to type a ring? No. So what you do with the condensed mixed structure is that the ring is the only thing that stays as bond line, and then everything else that's branching off of it goes to condensed. So as you can see, what I do is I take this thing, convert it over here, and now all of the branches coming off of the ring become a condensed formula. Does that make sense so far? Cool. I also wanted to talk about a few other things right here. Notice that with this, let's start off with this one because it's kind of easy, okay? What I have is, think about it, I have parentheses that has, does it have CH2 in parentheses? No. It's something other than CH2, right? It's actually CH3. So that must mean what? Does it mean that all the CH3s are in a line? No, that would only be if it was CH2. What it means is that all three CH3s are coming off of the same carbon. Does that make sense? And that's what we see right here. I have carbon, and then CH3, CH3, CH3. Does that make sense? Cool, I hope so. Now let's go to one that's a little bit trickier. That is this one over on the left-hand side. So now, what is this weird line that I drew? Like, where did that come from? This line is a pretend line, okay? So don't pay attention to it too much. All I'm trying to do is separate the right side from the left side to show you how we draw it differently, okay? Now, because condensed structure has to do with connection, it has to do with what is connected to what, when you're on the left-hand side of a mixed structure, you always have to draw in reverse. You have to put the letters backwards, okay? The reason is because I have to show exactly what order they're connected in. So let's look at this. This right here is an O attached to a CH3. Would you agree with that? Cool. But if I just write, instead of writing this, let's say that I wrote OCH3, like that. Would that be correct? That would actually be incorrect. So go ahead and put an X on that, okay? That would be wrong. The reason is because it looks like the O is attached to one of the H's, right? That doesn't make a lot of sense. So the way we need to show this is that the O is actually connected to the carbon first, and then the carbon is connected to three H's, right? So then the way that we draw it is O, C, and then H3 after that. Does that make sense? This only applies when you're on the left side, because if you're on the right side, then it just makes sense the way it naturally is. You would just write it out according to the connectivity. The left side is the part that gets a little bit tricky. Now, some of you guys might be asking this question, Johnny, but what if it's at the top or at the bottom? Because that's not really, how about if it's in between? So how about if I had a line right here and I wanted to put text there? Well, if it's right in the middle, then obviously go to the right, because I can just do CH3, O, or whatever. Or I could do, in this case, it would be O, CH3 if it had been there, okay? So obviously what I'm trying to say is that you would only go to the left, you would only reverse it if you absolutely have to because it's on the left-hand side. Does that make sense? But if it's at the top or the bottom, just go to the right like normal because there's plenty of room to draw it, okay? So let's go to the last example, which is this one down here that has a double bond to carbon into oxygen. That's this thing right there, okay? This is a situation where if you have a double bond, many times your professor is going to put an equal sign there. An equal sign represents double bond, which is pretty easy. If it was a triple bond, then they would put one of the equal signs that has 3 bars, okay? But sometimes your professors will be really tricky, and they will just write this like COCH3, and they will skip the equal sign. That's tricky, right? How are you supposed to know that that is a double bond without being told that it's a double bond? Can you guys think about it? Is there any way to know? The answer is it goes back to carbon having 4 bonds, okay? If this is a carbon and an oxygen, and if that carbon needs 4 bonds, then what that means is that this carbon must be attached to that oxygen with a double bond. The reason is because I have a bond on the left, I have a bond on the right, and then I must have 2 bonds that are missing. those 2 bonds that are missing are the ones that are attached to the O that make it a double bond right there. Does that kind of make sense? Now, like I was saying, most professors are going to be nice, and they're going to give you that double bond. But I'm just trying to show you, just in case your professor decides to be a tool and not put that in there, so that you guys will know that you can actually calculate it based on carbon having 4 bonds. Okay? So I'm going to give you plenty of practice, don't worry.